up, my co-chemist? So, a lot of people ask me, why did you choose chemistry? Well, I don't have an exact answer for that, but because chemistry is interesting. You can experience how substances change into another substance, or how a reaction works. So today, I will be making a black carbon snake experiment made out of baking soda, heat, and sugar. You will be wondering how black carbon snake be made. Well, check out this video. But in doing this experiment, make sure to follow safety protocols or precautions. Be safe because this experiment will be using fire and a very flammable fluid, so always take the proper precautions. You can do this experiment using stuffs you probably have around in your house. Sand is fireproof and works very well as an insulator, so it should keep the bowl protected when things start to heat up. The lighter fluid will act as fuel and helps maintain the heat of the flame for longer. To light the mixture, you'll need a long neck match or a long neck lighter. The lighter fluid will ignite very quickly, so don't get too close to the flame. After a little while, a large black blob will appear in the mixture and start to grow bigger.
After a while, the flames will start to go out and the snake will stop getting bigger. All of the baking soda and sugar have been used up at this stage, so there's nothing left to burn.
The black carbon snake is a chemical reaction between heat, baking soda, and sugar. Common types of chemical reactions include combustion reactions, acid-base reactions, and decomposition reactions. In the black carbon snake experiment, it demonstrates three chemical reactions. The sugar undergoes a combustion reaction because it's a reaction between oxygen and sugar that involves combustion, process of burning matter. The baking soda undergoes a decomposition reaction because it is broken up into multiple other substances. It decomposes into sodium carbonate, water vapor, and carbon dioxide. When the sugar and baking soda in the experiment combusts, it chemically changed into water vapor, solid sodium carbonate, and carbon dioxide gas. Heat is transferred through conduction. The lighter fluid conducts the heat and has direct contact with the sand, flame, baking soda, and sugar. While burning the sugar, it releases hot carbon dioxide gas and water vapor that rise because they are warmer than the air. However, complete combustion requires a good oxygen supply. Other complex processes take place at high temperatures because the flow of oxygen to the inner parts of the pile of sugar is hindered. So the sugar on the bottom is covered up and doesn't have access to oxygen, so it won't burn in a combustion reaction. Instead, some of the sugar undergoes thermal decomposition, a process that produces water vapor and solid carbon. As you can see in this, the snake is carbonate with black carbon particles. The pressure created by the carbon dioxide pushes the sodium carbonate out, which creates the black carbon snake. The hot gases that rise up help raise and expand the structure of the solid carbon and sodium carbonate to make a black snake. This reaction is referred to as the dehydration of sugar. The snake consists of mainly carbon that comes from the heated sugar, but which was not burnt in the flame. The carbon is what makes the snake black. There is also sodium carbonate in the snake, which results from the decomposition of the baking soda when heated. Combustion causes the exothermic reaction because energy is released. The overall process is exothermic, enough that the water produced in the reactions is vaporized. This steam, in addition to the carbon dioxide product, makes the snake lightweight and airy and allows it to grow to a large size from a comparably small amount of starting material. This is the finished product. Do you witness how amazing chemistry is? You can try this at home and make your own black carbon snake experiment. Make sure to follow safety protocols in doing the experiment. Hope you learned something from this video. Be safe and stay hydrated. Bye!